Okay, so we're on topic 14, economic analysis. I've got my own take on it, but let's just look at oh, they do. This is good. Yeah, they've got time value of money right in here. Life cycle analysis. Credits. Okay. So I'm just going to hit the big points here in chapter 15, and then I'll just give you one little example too. So chapter 15, economic analysis. What always entertains me about all of these things is how many different ways there are to refer to money. It's like, wait, you mean money? Oh, no, I mean that. No, money, yeah, it's all money, right? Yeah, right. Okay, so big picture here on the first page, just incentives. And these are things to get people to install solar panels who otherwise wouldn't. And you could do the same thing for oil investors too. They were like, hey, gosh, I want to really go exploring for oil, but I don't have any money. What do I do? Well, here's a incentive. Come, we'll give you tax breaks for however long. We'll give you access to labor, etc. But here are the types. Rebates. So that's going to mean you get sort of a discount. So the state government might have that, local might have it. The utility might have a rebate too, saying, buy it now, you'll get the money back later. Because the utility, what you're doing by putting your solar on, you're allowing them to not to have to go and find more energy somewhere else. So it should be to their advantage. So that's rebate. It's a little bit weird too, because you go to the store and you buy something, but you get the money back later. And that's the funny, weird thing about money is like the bank or the store or whoever actually has your money for a while. It's sitting on their bottom line, but not for long. There's a chance you might not go in and cash in the rebate too, in which case they're gambling a little bit with your money. Mm-hmm. Professionally, legally. Grants are another one. Good example, that PV trailer that's sitting out back right now, that was a grant. $100,000 came from the National Science Foundation because the NSF values clean, renewable energy education. Northwestern Energy also chipped in $40K because they want to have locally trained PV installers working in the state of Montana.
So is the difference between a grant and an incentive that one's the government subsidized and one's private? Or?
A grant is a type of incentive, and under the primary sponsoring entities, private is not listed here, and typically you would not, well, I should take that back. The Gates Foundation gives grants. Mm-hmm. Microsoft typically doesn't. Microsoft might invest in a school and say, hey, here's money to go build a school. That's got a different name, but mm-hmm. A grant is just money that you get and you don't have to pay it back. Yeah. It's just there to go into the greater good. And you can see of the different five, the feds give grants, state gives grants, local governments give grants. The utilities, I just mentioned Northwestern Energy, and nonprofits, the Gates Foundation being an example of a nonprofit that gives grants to solve AIDS or hunger in Africa or whatever. Okay, loans means somebody's got a bunch of money sitting there right now, you don't, they give it to you with the expectation you're going to get it back. Tax incentive. Meaning, hey, go ahead and spend your money on this. We're not going to necessarily give you your money back, but we realize that by putting in PV, it's likely that you're not going to be pumping as much CO2 into the air by tapping the coal-fired power plants, et cetera. We'll pay you back for that, so you don't have to owe the Fed as much, so we don't have to go and do a Superfund site for the next coal mess or whatever. Okay. Production-based incentives. Meaning we'll pay for the electricity. And then renewable energy certificates. CERT just means that you've demonstrated that you've got, and that's the least understood. So I'm just gonna pop out to renewable energy certificates and just read from the book. So renewable energy certificates are similar to production incentives, which is what we just saw a second ago. A REC is a tradable commodity that represents a certain amount of electricity generated from renewable sources. So you've got the PV system in place, you're making electricity, there's a certificate of that because it's going to show up on your power bill, and that's valuable to some people. RECs are also known as renewable energy credits, green tags, or tradable renewable energy certificates, TRCs. RECs are not necessarily sponsored by government entities or utilities. That's why they're in that nonprofit column. Rather, they are facilitated by organizations that arrange the transaction and keep a small percentage for their services. So let's just keep reading. An owner of a renewable energy system, such as a PV system or wind, receives one REC for every 100 kilowatt hours of electricity produced and exported to the grid. So you might get some money, you're going to get some electricity, but you also get this third thing called a REC. See figure 513. So here's the figure in the book. I'm just going to hold it up to the screen, and then I'm going to kind of dial through it briefly. So we can see at the top you've got fossil fuel distributed to a substation, comes onto the grid. Meanwhile, you've got somebody here with their house, they've got wind, they've got solar. The REC goes out to the utility customer wishing to cooperate with renewable energy. So that's this little box over here. The certificate goes to that third party from the house, and some money comes back. Typically not a whole heck of a lot, but that's how the system works. Basically with three parties. The fossil fuel grid sitting up here, the utility customer wishing to operate. And basically what they're doing is saying, I want to buy electricity, but I don't want to buy it from the fossil fuel industry anymore. That's kind of what's happening right now with Washington State saying, well, we like electricity, but we don't want to buy it from Colstrip anymore. Sorry. So they might say, gosh, Montana, here's a bunch of money to start sticking solar on your roofs so we can still keep the electrons flowing from, large, less populated place into population centers like Seattle. So that's the REC market. Kind of convoluted, but there it is. Okay, next thing is the cost analysis. And if you guys take 214 in the spring, you're going to get a major dose of this. It's fun.
Which one is 214?
214 is energy storage and distribution. So PV electric is just kind of one example of electricity or energy distribution. It's electrical energy distribution. Kind of hard to distribute heat. It happens. In 242 we talk a little bit about district heating. And then storage of electricity is also an issue. I mean, just as soon as it's made, it has to be consumed somewhere, unless you're sticking capacitors on the grid or building Gordon Butte, or there are even plans for doing gravity-based storage based on abandoned railroads, where you just send your rail car uphill electrically and then bring it back down. So yeah, so then there are giant geoengineering projects underway in that system. Okay, now here's one little view of how that works. I'm just kind of looking at this next page. The dollar bills right up here, that's sort of your initial cost. That's where your big investment comes from. And I'm gonna hop into this website. You get a chance. There are 6 simple formulas. Well, not so simple, but simple enough. 6 simple formulas for calculating time value of money. And this is fundamental. So there we are. 1, 2, 3, 4, 5, 6. This is fundamental to all banking. Whether you're talking energy, biotech, automotive industry, any type of investor you're going to make. 3 different ways to think about money. There's the present value. So you've got the dollars in your pocket, and the idea basically is that a dollar is worth $1 now. It might be worth more in the future. It might be worth less in the future, but you sort of agree to what's $1? Well, it's sitting right there. You can get into some other arguments that $1 is going to be much more valuable to someone who has fewer dollars than someone who has more, right? Because that's why one person might go to dinner at Plonk and someone else goes to McDonald's, right? Because that dollar is going to be turned into calories, or versus social experience or whatever. But the fundamental notion is that a dollar is just worth $1 now. Where does this stuff start coming in? So let me, I'm going to pop out to a spreadsheet that we use all the time in 214 before I start talking about what A is, because these 2 formulas are quite simple. So I love looking at this and I teach a lot of courses. Love it. All right, so learning unit 1, learning unit 2, equiv. Okay, so what I've done here with this little spreadsheet is just taken these 6 formulas and turned them into Microsoft Excel. Because every time I work this thing, I don't want to go down, pencil, paper, use some exponent, whatever. But let's just find the future value of a certain amount of money. If we know the present value, and again we say, okay, $1 now is worth $1 now. The 2 other things we need to know is what the interest rate is. And if you've been following federal economics, the interest rate is the federal interest rate is tiny, it's low, it's just a fraction of a percent. Some governments now have their interest rates negative, where money starts, it's called devaluing your currency. It starts, and it's weird. I've met these people who are doing Japanese investing, and so the Japanese have all these dollars, these yen, just sort of stockpiled, because they don't want to put them in the banks there. They want to put it somewhere where the value is going to go up. So that's why you start seeing Asians buying chunks of North America, because they believe that this real estate is going to have greater value. It's where people are going to move to and build, develop, etc. And then N is how many years the agreement rolls for. And so you could think of this as your 30-year mortgage, for example. You got a 3.5 fixed. Where you get in trouble, or when you start to get down in these other weird exponentially increasing, gradient increasing, et cetera, et cetera. Those are your balloon mortgages, which were sort of responsible for a lot of what happened in 2008. So we're just going to stick to the top, like, whoa, no, thank you. But we'll just stick to this top formula up here. Okay. So let's just say, for example, we're going to run for 10 years, and let's just let the interest rate be, let's just let it be 10%. And let's just say we're going to put in $1,000. So you might naively say, well, if I had $1,000 and I was going to get 10% back for 10 years, let's just pencil that out. Let's just kind of pencil it out very naively. So if I had $1,000 now, and then at 10% for 10 years, you might just off the top of your head say, well, I'm going to get $100 per year times 10, that equals $1,000. So at the end of 10 years, I should have $2,000, because my initial 1,000 plus that $100 per year for 10 years, I should have 2,000. Well, it's more than that, and the reason is because at the end of that first year, I had a 1,100, and I started making interest on that. So it does compound. And the formula for doing that in Excel is I take this initial B6, which was the initial amount. So if we can go back to the thing, the initial amount, the present value, that was P, that was the 1,000, sitting right there in B6. And I'm going to multiply this by 1 plus B4, which is 1 plus the interest rate. So there it is, 1 plus the 10%. And I'm going to take it to the 10th power, which is sitting there in cell B5. Okay, so that's the easiest one to sort of get and understand. This one is a little different, but it's the same thing in reverse. It just tells me if I want $1,000 in the future and I can invest it for 10 years at 10%, I need to put in $385 now. And at that rate, I'll have $1,000 in 10 years. Okay, so those are the two simplest. And like I said, there's 6 total functions. Get rid of G there for a second. A is just the annuity. It's how much you pay per year. It's what you pay on your mortgage each year. And so again, you can convert between the future value of money and what you would pay on an annual basis, or what something's worth right now, what you pay on an annual basis. So let's look at that in the spreadsheet too. Nice thing about the way we set this up in 214 is you just enter those 3 numbers, you know, the principal, the number of years and the percentage, and the rest of them just fall out, because you can see each one of these cells calls on those 3 clusters. Okay, so so the way these are written, it's a little confusing, but that's the way the accountants like it. Is you put in this number and you get this one out. So you can also think of it like most math problems, the way most math problems are written. And let's just say, find future value with present. One way to write that would be to say that the the future value equals some function of the present value. The way it's written on the spreadsheet in a lot of accounting documentation is just to say F/P. In both cases, your input is on the right and your output is on the left. And that's typically how you solve any algebra problem. You stick everything you know on the right, and what you don't know comes out on the left. Okay, so nothing too crazy with that. All right, so the P versus A, this means that if I put in if I put in this is a little more subtle. I can either put in $10,000 now, or I can put in $1,000 per year as an annuity. It also means if I could put in $162 as an annuity, which is the same as $1,000 now. The future value, if I put in $1,000 a year for 10 years, I'm going to have not 10,000, but I'll have almost 16,000. And then same thing here. If I put in $62 a year, I'll have $1,000 in 10 years. So that's how those 6 different things are related.
Now, like for the annuity, you get if you put in $1,000 in the present, that's averaged over the 10 years. You actually wouldn't get 162.75 per year. You'd get like 110, then 121, and then.
Yeah. Let's look at that one a little more carefully. So the P versus A, and what I typically do is take this kind of way down. Let's just say 0.01%, even less. 0.01. Oops, I'm too crazy with the zeros. 0.001. So to answer your question, the short answer is no. The short answer is that I can either have $1,000 now that I'm going to invest for 10 years at 0.1%, or you could have $155 every year. Exactly. You can have one of the two. So the annuity itself is fixed.
Mm-hmm.
It's a fixed annuity.
Okay, so
you wouldn't get the other those other models are more complicated, where you might get so it's not an average, it's just that many dollars in whatever that year's dollar is worth.
Mm-hmm. Yeah, and ultimately it's saying that box is saying if you invest $1,000 over 10 years, you'll get this much annuity per year.
Yeah, it's saying that $1,000 invested at 10% over 10 years is the same as getting $155 per year.
Totally.
Yeah.
But if you wanted to figure the actual amount you're getting per year, you'd have to list each iteration of the equation, right?
Yes, yeah, I do know what you're saying. And there are problems like that. What you have to do is go back and do both a 5-year and a 4-year analysis, and subtract the 4-year analysis from the 5-year analysis.
And just keep doing
Yeah, you have to do it iterative. Yeah.
Yeah.
And there are ways to do that, but I don't want to get too crazy. Yeah, for sure. No, but that's absolutely right. Okay, so that's short version of the time value of money. The book has a table that's basically just all the factors that we just looked at. So if you want to look it up, you're sitting there and didn't have your calculator handy. They're in there just like all the trig tables used to be. The key though, let me show you the key though. Oh, I know what to show you. This is great. Somebody asked me the other day, do solar panels actually pay for themselves? Someone says, doesn't it take more energy to make a solar panel than they give back? The answer is no. And it comes out to about 2.5 years though. Let me show you. Actually, let me take a break and then I'll show you. It's a really good problem.